Hello everybody. Once again I am here with you with the new session that is van der Waals equation of state is to be there. And in this basically what is the ideal gas or real gas equation is to be there. PV is equal to RT. Van der Waals given suggestions and corrections in this, and why there is need to correct this real gas or the ideal gas relationship is to be there. That is also we will see in detail. So when this uh, perfect gas relation, sorry, PV is equal to RT is to be considered, and in that case the two things are neglected or assumed that the atoms or the molecules of the gas are point particles and their size is negligible. So the first point was this size of the gas molecule is neglected, and that is what the first step where the PV is equal to RT is taken into account with the assumption that atoms or the molecules gas molecule size is to be negligible, as it is very tiny is to be there. And the second part, which is to be intermolecular forces of attraction between the atoms of the gas molecule, is absent, that is to be as not considered. That intermolecular forces of attraction in between the molecules is not taken into account. And these are the two basic things where the basically the assumption was to be taken into it this way, and due to that PV is equal to RT is written. But in actual practice the high pressure, uh, the size of the molecules becomes significant at the particularly high pressure. The whatever be the size of the molecules become significant, that can be considered, that cannot be neglected. And that's why the volume of the gas is going to be uh, as compared to the volume of the gas, it is not taken into account. That is not correct. And again, the forces of attraction, as the atoms come closer, they definitely interact with each other, and due to that these two things which are very important for affecting this PV, pressure and volume, is going to be affected. And that's why there is correction according to the van der Waals suggestions are to be there. And that's why the van der Waals given equation of the state is to be there. So considering these two factors, what exactly correction in the pressure, and why there is to be as a correction in the pressure is to be there, and how it is going to be affected with the how much amount is to be there. When the gas in this container is going to be agitating, moving here and there, the whatever be the internally each molecule is going to be attracting each other, and therefore the forces, the resultant force acting on the molecule is going to be zero in that stage. And that's why the wherever the molecules are also going to be moving here and there, they definitely strikes the wall of the container is to be there. So as soon as they strikes the wall, there will be definitely another molecule will attract it. So this is what the important factor, where if you look at this diagram is also given here, that if you look at this is what the molecule at the center, where there will be forces of attraction in all the direction. Due to that the resultant force on this molecule will be zero. That means in this direction the force is to be there, in this direction force is there, in this direction force is there, in this direction force is to be there. So resultant force acting on that molecule will be zero. But when it strikes the wall, at that time definitely another molecule attracts towards another direction. And in this case, where there is a correction in the whatever be the velocity, that means striking the wall and back, attracted by the another molecules, and that is somehow the momentum is also going to be the part. And that is what, while in absence of these forces striking the wall, and in presence of this striking the wall, it will cause the difference in the pressure. And that is what because not a single molecule is going to be striking, the number of molecules are going to be striking, and that will cause to the again the factor which is to be the what exactly the molecule the gas molecules density is to be there. And that's why the correction in the pressure is to be there, and actual practice whatever be the pressure is to be there maximum as compared to the noted or the recorded is to pressure is to be there. And that's why the number of molecules striking the wall of the container per unit area per unit time, and that is also taken into account. And here this part will affect to the correction the number of molecules present in the gas molecules both have the factors depends on the density of the gas. Definitely what density is to be there, either two things are there: number of molecules striking the walls per unit area and per unit time, and the number of molecules present in that container is to be there. And that is what the density volume both the above the factors depends on all the factors depends on the density of that gas is to be there, because it is striking and coming back. So this will cause to the correction definitely related with the density part, and that's why the correction in the pressure will be proportional to the density part, and that's why P is directly proportional to the rho square, which is directly proportional to the 1 by V square is to be there. So the correction in the pressure, that is small P, is nothing but to be given with A upon V square is to be there. This A is constant with the proportionality removable is to be there. So that's why this A factor, A is nothing but to be a constant of proportionality, and V is nothing but to be a volume of the gas is to be there. Hence the correction in the pressure will be capital P plus small p, that is the correction, is equal to P plus A upon V square is to be there. So P is observed pressure and the small p is to be the correction plus the A upon V square is to be there. So this is what the correction in the pressure is to be, simply giving us the whatever be the A upon V square is to be the value. So this is so here by mistake it should be the capital P, because small p ची व्हॅल्यू जी आहे A upon small v आहे, मग इथं small p चुकून आलेला, इथं it should be capital P is to be there. So the correction in this particularly pressure will be capital P plus A upon V square is to be there. So this is what the correction in the pressure according to the one rule. And about the correction in the volume, the as the molecule size is going to be finite, and again there is a limit of whatever be the actual space available of the available for the movement of the gas is less than the volume of the vessel is to be there. That means to be uh, there is a chance of expanding the gas molecule up to certain level. And if suppose let's r be the radius of that gas molecule, and in that case the whatever expansion of the gas that comes to the influence flare sphere of influence of the gas molecule is to be there. So suppose r be the radius of the molecule of one molecule, and the volume will be given x is equal to, as it is circular, that's why 4 pi r cube by 3 is to be there. But as far as the factor is very important, which is the two molecules, when the two molecules touch each other, the distance between their centers are 2r. That is in this diagram it is shown, there are the two molecules, here is one, here is another one. There is r radius for this first molecule, this r is for the second molecule is to be there, and that's why this r plus r 2r is to be there. So two molecules touch each other and the distance between them, their centers, is only 2r. So the two molecules come closer to each other with the minimum distance between their centers is 2r. And therefore the volume of the sphere of influence of each molecule, volume of sphere of each molecule will be, it is concerned to be as an 2r. जर मॅक्सिमम हा किती वाढू शकतो क्लोजर कॉन्टॅक्ट आला तरी ह्याच्यामध्ये, तर मॅक्सिमम 2r एवढाच हा व्हॉल्यूमचा पर्टिक्युलरली स्पियर ऑफ इन्फ्लुएन्स हा that is S is equal to, here the value will be given, that is 4 pi. 2r is the radius, that's why, means influence किती होऊ शकतो, maximum sphere of volume किती वाढू शकतो, it is 2r cube upon 3, and 2's cube is 8, and that's why it is to be written as an 8x, where the x is nothing but to be remaining part, where it is to be as an ह्याच्यामध्ये ह्या यसला एस 8x जेव्हा लिहिलेला आहे, इट इज काउंटिंग ऑल दॅट फॅक्टर्स, रिमेनिंग पार्ट विल बी एक्स ओनली, दिस इज व्हॉट टू बी ॲज अन 2 क्यूब दॅट इज 8 होते, आणि बाकीच्या पार्टला इथं 4 पाय आर क्यूब बाय 3ला एक्स कन्सिडर केलं. तो सिम्प्लिफिकेशन म्हणजे जास्त इक्वेशन मोठं होऊ नये त्याच्यासाठी, स्मॉल करण्यासाठी त्याला व्हेरिएबल एक्सनी नोट केलं. सो यस इज नथिंग बट स्पियर ऑफ इन्फ्लुएन्स, मॅक्सिमम मोठा होण्याचा चान्स त्या मॉलिक्यूलचा, दॅट इज टू बी ॲज अन 8x इज टू बी देअर. Now interesting part, if suppose the if the molecules are allowed to enter the container, म्हणजे आता जर समजा एखाद्या कंटेनरमध्ये जेव्हा मॉलिक्यूल एंटर करायचे तर त्यांना अवेलेबल असणारा स्पेस किती असेल. एक सिंपल जर एक उदाहरण बघितलं तर एक क्लासरूम आहे ज्याच्यामध्ये की 50 विद्यार्थी बसू शकतात अशा सीट्स आहेत. तर पहिला येणारा विद्यार्थीसाठी किती अवेलेबल स्पेस असेल, तर 50 सीट्स, टोटल व्हॉल्यूम विल बी 50, आणि त्याला अवेलेबल स्पेस 50 सीट्स आर टू बी देअर. मग तो दॅट इज नथिंग बट टू बी द व्हॉल्यूम फॉर द फर्स्ट मॉलिक्यूल इज नथिंग बट टू बी व्हॉट एव्हर द साईज ऑफ दॅट कंटेनर इज टू बी देअर. म्हणजे पहिला जो मॉलिक्यूल येणार आहे त्याच्यासाठी अवेलेबल स्पेस किती असणार आहे, त्याच्यासाठी अवेलेबल स्पेस ही टोटल व्हॉल्यूम त्या कंटेनरची राहणार आहे. आता सपोज पहिला जो काही मॉलिक्यूल आहे तो आला, त्याचं जे व्हॉल्यूम, त्याचं पर्टिक्युलर स्पियर ऑफ इन्फ्लुएन्सनुसार व्हॉल्यूम आपण किती काढलेले, यस तेवढी तो जागा घेणार, एक सीट एवढी जागा घेणार. जेव्हा सेकंड मॉलिक्यूल येईल त्याला अवेलेबल स्पेस किती असणार आहे. सिमिलरली जर मी जसं म्हणलं की बाबा 50 चेअरची एक किंवा 50 विद्यार्थ्यांची कॅपॅसिटी असणारा हॉल आहे, त्यापैकी एक जण आला, त्याला अवेलेबल स्पेस त्यावेळेस किती होती, 50 स्टुडंट, म्हणजे 50 पोझिशन्स होत्या, त्याला 50 जागेपैकी कुठेही बसता येत होतं. मग तो एका जागेवर बसला, तर दुसरा विद्यार्थी जेव्हा येईल त्याच्यासाठी अवेलेबल स्पेस किती असेल, 49, दॅट इज 50 मायनस 1, 49 स्पेस विल बी, म्हणजे त्याला 49 सीटपैकी त्याला कुठेही बसता येईल. म्हणजे एकनी सीट कमी झाली, म्हणजे अवेलेबल स्पेस त्याच्यासाठी झाला 49. इन द सेम वे, जसं की पहिला मॉलिक्यूल जर आला तर त्याने जी काही जागा कॅप्चर केलेली आहे ती किती केलेली आहे, दॅट इज व्ही मायनस यस इज टू बी देअर. यस स्पियर ऑफ इन्फ्लुएन्स तो किती जागा ऑक्युपाय करू शकतो, तर मॅक्सिमम यस एवढी. मग सेकंड मॉलिक्यूलसाठी अवेलेबल स्पेस जो आहे, सेकंड मॉलिक्यूलसाठी अवेलेबल स्पेस आहे, दॅट स्पेस इज नथिंग बट टू बी हिअर ॲज व्ही मायनस यस. जसं मग आता सेकंड विद्यार्थी आला, त्याला अवेलेबल स्पेस झाली 49. मग त्याच पद्धतीने थर्ड स्टुडंट आला, थर्ड स्टुडंट जर आला तर त्याच्यासाठी डेफिनेटली पोझिशन्स अवेलेबल विल बी 48. सिमिलर वे, मग थर्ड मॉलिक्यूल जर आला तर त्याच्यासाठी अवेलेबल स्पेस किंवा व्हॉल्यूम अवेलेबल हा किती असणार आहे, व्ही मायनस 2s. डेफिनेटली 2 मॉलिक्यूल बसले, त्यांनी जेवढा स्पियर ऑफ इन्फ्लुएन्स एवढी जागा घ्यायची होती तेवढी घेतली. मग अशा पद्धतीने जर समजा एकच मॉलिक्यूल किंवा 2 मॉलिक्यूल नसतात, एक गॅस कंटेनर, म्हणजे जेव्हा केव्हा गॅस कंटेनर आहे एखाद 2 लिटरचा आहे, तर 1000 मॉलिक्यूल्स किंवा लाखो मॉलिक्यूल्स त्याच्यामध्ये येणार. मग एन नंबर ऑफ मॉलिक्यूल्स जर येणार असतील तर त्याच्यासाठी अवेलेबल स्पेस किंवा त्याच्यासाठी असणारी जो काही व्हॉल्यूम अवेलेबल आहे, दॅट व्हॉल्यूम अवेलेबल फॉर द nth मॉलिक्यूल 100वा असेल तर व्ही मायनस 99s असं आपण जसं म्हणतो. तर त्याच पद्धतीने nth म्हणजे किती असू द्या, लाख असू द्या, 1 करोड असू द्या, द nth मॉलिक्यूलसाठी व्हॉल्यूम अवेलेबल विल बी व्ही मायनस n मायनस 1 यस इज टू बी. आपल्याला माहिती आहे, जर समजा 100वा मॉलिक्यूल असेल तर त्याच्यासाठी आपण अवेलेबल स्पेस किती म्हणतो, व्ही मायनस 99s. म्हणजेच काय, त्याच्यामध्ये n मायनस 1, 100 मायनस 1 दॅट इज 99, यस एकची जागा, ह्यानुसार त्याला अवेलेबल स्पेस आपण लिहू शकतो. जर समजा मला ॲव्हरेज स्पेस अवेलेबल फॉर इच मॉलिक्यूल जर कॅल्क्युलेट करायचं असेल तर मला काय करावं लागेल, इट इज टू बी, आय हॅव टू डू with the same way divided by n. म्हणजे समजा 10 जण येणार आहेत तर v मायनस 9s अपॉन 10 इज टू बी देअर. सो त्यानुसार जर समजा मी टोटल ह्या पार्टला किंवा ह्या मॅथमॅटिकल पॉईंट ऑफ व्ह्यूनी जर समजा मला अवेलेबल स्पेस फॉर इच मॉलिक्यूल जर लिहायची असेल, किती मॉलिक्युल्स येणार त्यानुसार, तर दॅट आय कॅन राईट व्ही प्लस व्ही मायनस एस प्लस व्ही मायनस 2s जितके काय आहेत एन नंबर ऑफ मॉलिक्युल्स जेव्हा केव्हा येणार आहेत. मग त्याच्यासाठी मी असं लिहू शकतो की इट इज नथिंग बट टू बी प्लस व्ही मायनस एन मायनस 1 in bracket close yes upon n is to be there. So this is what the equation I can write. So I can correct it with the another way or simplify it with the another v minus s into 1 plus 2 plus 3 plus 4 जे काय continuous n number of molecules जेव्हा येणार n minus 1 upon n is to be there. So this is what the available space. Now finally I can correct it with this way, v minus s into n minus 1 into n by 2n is to be there. म्हणजे बघा सेकंड किंवा फोर्थ किंवा 10th मॉलिक्यूल जर असेल तर त्यानुसार इथं जर बघताल तर त्याच्यासाठी अवेलेबल असणारे स्पेस जर समजा सेकंड मॉलिक्यूलच जर घेतला तर इथं काय होईल, यांची व्हॅल्यू 2 झाली, 2 मायनस 1 1 आणि इथं बाहेर 2च राहणार, n म्हणजे 2 आहे. मग 2 इंटू 1 2 म्हणजे 2s डिवायडेड बाय 2n म्हणजे अगेन 2 इंटू 2 4 दॅट इज बे बे दोन्ही 4 म्हणजे s बाय 2. v minus s by 2 will be the average space available for the second molecule. म्हणजे प्रत्येकाला एक एक त्यानुसार s जो आहे म्हणजे ॲव्हरेज स्पेस फॉर द 2 मॉलिक्युल्स विल बी v मायनस s बाय 2. दोघांना पण अर्धी अर्धी डिव्हाइड करून व्हॉल्यूम जर समजा 2 सीट्सचा असेल तर दॅट इज त्यानुसार त्यांना दोघांना एक एक सीट्स असं अवेलेबल होऊन जाईल. So it is nothing but to be according to that this formula or this is simplification is to be given. Now this is somehow simplified for the average space for each molecule is to be there. आणि ह्याच केसला जर समजा आणखीन थोडंसं सिम्प्लिफाय जर केलं तर इट इज नथिंग बट टू बी गिव्हिन मी इज इक्वल टू व्ही मायनस ऑफ एन एस बाय 2 प्लस एस बाय 2. But as far as s by 2 is going to be concerned, it is very negligible as compared to ns by 2, very small as compared to the average. The number of molecules is very large. म्हणजे आपल्याला माहिती की एका कंटेनरमध्ये 1 लिटरच्या लाखो मॉलिक्युल्स असू शकतात, तर त्यामुळे त्याची साईज ही खूप जास्त आहे. मग त्या कंपॅरेटिव्हली एस बाय 2 इज व्हेरी स्मॉल, निग्लिजिबल as compared to ns by 2 is to be there. So neglecting this s by 2, what is the available space for the average available space for the each molecule is to be there, it is v minus ns by 2 is to be there. So again putting the value of this s, आपण s ला जे लिहिलं होतं ती व्हॅल्यू जर त्याची इथं पुटअप केली तर इट इज नथिंग बट टू बी नियरली 4x is to be there and sorry 8x is to be there. आणि s ची व्हॅल्यू आपली 8x जर इथं पुटअप केली तर डिवायडेड बाय 2 म्हणजे बे चौक 8, दॅट्स वाय इट इज v मायनस 4nx is to be there. आणि ह्याच 4nx ला एक व्हेरिएबल दिला b and that's why the correction in the particularly volume is going to be concerned. It will be given actually 4 times the actual volume of the molecule is to be there. 4x is nothing but to be where b is equal to 4nx is to be there. In that case the van der Waals equation of the state for the real gas will be given with the relation, that is the for the pressure it is nothing but to be p plus a by v square into v minus b is equal to rt is to be there. So this is what the van der Waals correction for the real gas or the pv is equal to rt is correction, and a and b are van der Waals constants are to be there. So this is what the case where the van der Waals suggested the two important what we learn, that while the real gas relationship is pv is equal to rt is written, that time the two things are not taken into account. That first one is smallest size or the finite size of the gas molecule is not taken into account. Secondly, the forces of attraction in between the molecules are not taken into account. And assuming that negligible part pv is equal to rt is written, but van der Waals considered that both the things and suggested a correction in the pressure and the volume. And that's why the new corrected equation of the state for the real gas by the van der Waals is to be P plus A by V square into V minus B is equal to RT is to be there. Again, thank you for joining this session. Be at home and be safe. Thank you.